So welcome to the Mentored Engineer. In this video, we are going to talk about administration control of IoT systems. So I'm here with Clay Counts again from Sealevel Systems, and we're going to talk about IoT administration. And first question I have is, how much of this can be done, of your system can be done remotely?
Yeah, so really the IoT, that's the beauty of it, is by nature a remote device. You can, of course, use it places where there is network access, but really anywhere that you have cellular, our device will work.
Okay. So can you actually control a machine from far off, maybe even another country?
Absolutely, yeah. So you could be on the other side of the world and use our controls. Now, our device is fairly general. It has very general controls on it, so it may not be great for, say, doing a CNC machine, something like that. Not to say that that technology won't exist someday, but our device is a fairly general device that maybe you could use to control a gate, a lift station, a pump, a light switch. There's a number of things that you can use to control things from far away, whether that be across town or across the country or across the world even. You can use our device to do it.
Okay. Now, some of our listeners may be familiar with the SCADA system, which is a supervisory control and data acquisition system. How does this different?
So IoT is a little bit different than SCADA. I guess I should say it can work hand in hand with it. Whereas a SCADA system, you may normally think of that as being a networked in system where somebody can connect in directly via cable, whereas an IoT can tie in to a SCADA system and work remotely. So instead of everything being connected via network, the end user can have remote sites that are miles and miles away from each other that he can connect to and use, monitor data, control, all from our cloud service.
Can you give some examples of when having a remote override of a system would be beneficial, even if there's an operator right there?
Yeah, absolutely. So let's think about wastewater management. So that's a good example. These sites are usually remote, but there can be an individual on site to monitor, control, make sure things are in order. You can have thresholds set where, say if your person on site's maybe not paying attention, they've moved, they're working on something else, where another individual can get an alert when a pump level, or a tank level rather, gets too high to actuate a pump. So even if you have somebody on site there on hand, they can get an alert and say, hey, tell this guy to go turn the pump on, or I'm going to go ahead and do it myself from our cloud system. It's very handy in those type of applications, and that's just one example. There's a number of different ways that these can be used.
So Clay, how would you use the IoT, even if you already had a SCADA system on your device, to monitor and manage production?
Yeah, absolutely. So in that situation, this is where IoT would shine as an analytical and data management type platform. Obviously, you can use our IoT device for controls, but in this case, it'd be wonderful for analytics for monitoring things like number of units run, water flow, pressure, and use that for a bigger picture, and even as we get towards AI, monitoring trends, data, make predictions, make projections, make tweaks into your system to really fine-tune it. So in this type of situation, it would really shine as a data management platform.
Okay. Now you mentioned that you can monitor trends and look forward. Is that mostly for maintenance, or would there be some other things that you could gather from that?
Absolutely. So maintenance is a great way to do that. Projections of how long it's going to take you to do something. And it's also great for making tweaks. So you can monitor large facets of data across different areas, make a small change, see how that impacts, and say, okay, that was wonderful, we'll keep doing that, or change it a little bit more if it didn't help. So that's a great way that IoT can help you in that manner, not only for tracking, but also making changes.
So Clay, looking at our device here, it prominently has a cellular antenna on it. Why would we choose to use cellular over Wi-Fi? And is there some reason from an administration standpoint that you would want one or the other?
Yeah, absolutely. That's a great question. So sometimes it has to do with a lack of Wi-Fi in the area. So obviously you'd have to use cellular if you want a connection. Another thing we've run across is a lot of companies, oddly enough, even if it's one of their employees doing it, they don't like you tying into the network with a third-party device. So even if we're in, let's say, a pharmaceutical company to monitor the temperature of the pharmaceuticals, they wouldn't give us access or give their users access to their network, even though there's Wi-Fi throughout the building. So they would use cellular in that case, and that would solve that problem. Also, cellular is a fairly encrypted form of communication to provide data in a safe way that's tough to hack and tough to get a hold of. So that's another benefit of using cellular versus Wi-Fi. Really boils down to practicality, what you need on your end. From our standpoint, your data will be sent to the cloud either way, whether it be through Wi-Fi or cellular. But depending on your application, you may prefer one or the other.
All right, well, thank you for joining me, Clay. Thank you for watching this episode of The Mentored Engineer, and we will be back next time with Clay here to talk about designing IoT systems. Thanks for watching this video. Please visit us at www.mentoredengineer.com and do a search for calculators. We have some phenomenal state-of-the-art calculators. Our team has worked so hard, and we are so proud of these calculators. We have calculators for hydraulics, including pumps, motors, cylinders, and hoses. We have different pin calculators, and we have the ultimate beam calculator. So please go there, check it out, and sign up for your free 30-day trial.